Now we have entered into the third part where we will be discussing the next type of reaction, that is known as
displacement reaction.
So
Okay.
it says that when an element or radical has replaced another element in a compound, that is known as substitution. Okay, or we can say displacement. Both are same. Okay, displacement is also known as substitution. Substitution means replacing the value. We know that one. Replacing element. Okay, so if you see nicely, see here this is an individual. They are in compound form. Okay, so means this one can be an element. Okay, this one can be an element. Okay, can be an element or a radical. Okay, so this can be an element according to the definition or radical. Okay, and it has the power or ability to displace or displacement or substitute. Okay, so another one. Okay, it is always an element. So it is an element, it is also an element. See, so it is having the power, so it will pull this z towards this one. Okay, so it will pull the z towards x. So x is having the ability to pull the z towards itself. So now what will happen? So y will be alone. So x and z will form a compound. Okay, so into the topic which we are going to discuss, that is displacement reaction. It is also known as substitution. Okay, so there are two different names. Okay, displacement, if they are saying it's same thing, and substitution, both are same thing. So what they say, when an element or radical, okay, so remember, when an element or radical, so they are focusing on this one. So it can be element, it can be a radical. Okay, has replaced another element. Okay, another element is there. Okay, in a compound. So what they are saying, the one who is replacing, okay, the one who is replacing, it's always an element or a radical. To whom it is replacing is always an element in a compound. So it's an element in a compound. Okay, so part of the compound. So if you see this one, if you see the reaction, x plus yz arrow y plus xz, means what, from here what we came to know, means x is replacing y from its place and forming a new compound with a z. Yes sir, x and z. So from here we came to know x is a element or radical. Okay, which is replacing y. So y is always an element. It's a compound. In that compound, y is an element. So now y became an element, individual element, and x and z form a compound. Okay, so that's what I'm saying. When an element or radical has replaced an element in a compound, that is known as displacement or substitution. Now how it is doing? So how you came to know that is more power, that it has the power to displace? Why it is? From where you came to know? By using the. So according to the definition, what I am trying to say is that this can be an element or radical. We understood. Okay. Now what it has to do? It has to displace or substitute. Okay, substitute that one. So what it will do? If it is having if it is a powerful element or radical, it will displace one more element. Okay, it will always displace an element only. Okay, the one who is displacing, it can be element or radical. So to whom it is displacing, it is always an element. Okay, so it will displace an element. Okay, now it will form a x and z as a compound. Now it will become an element. It will still be an element only. Okay, so now you understood what is trying to do. Displacement is nothing but removal. What? Replacing another element in a compound. When an element or a radical, so it's always an element or a radical has replaced, so it can replace another element. So for example, now what is trying to do, it is replacing y. X is replacing y and forming a new compound with z and forming a x and z, and y is alone. So now y became an element and it forms a compound. Understood this one? Now you will ask me, how sir you came to know that x is having the ability to displace, okay, this one. Okay, so as to form x and z, we will decide according to the reactivity series. Now sir, what is reactivity series? So the one which is lying there, it's a reactivity series. If you will see, all the elements are arranged in some particular pattern or an order, that is a reactivity series. This is a reactivity series for metal. So what do you mean by reactivity series? So it means that, see, if you will see the elements of potassium, sodium, calcium, magnesium, and everyone is there. Okay, they have been arranged in some particular manner. Okay, so hydrogen also, hydrogen has been also included. Okay, so you see the way they have arranged. So the one which is at the top most, it's more reactive, most powerful one. Potassium is there, after that sodium is there, calcium is there, and so on. So the one which is at the top is more powerful, potassium. So it has the ability so as to displace anyone who is below to them. So show with an example. Okay, I will show with an example. So you understood this one. This you have understood what I am trying to say. Okay, sir, that one you show with an example. Also said the one at the top is more electropositive as compared to the one at the lower end. So the one at the top is more electropositive one metal, which has the power to displace the less electropositive one which are below from in an aqueous solution. You understand aqueous solution means water solution. You may ask that, sir, it's a reactivity series, electrochemical series regarding metal. Sir, can we have for non-metal also? Non-metal also you having the same thing. You'll have the one at the top is more powerful as compared to the one at the lower end. The same thing is there. Okay, but we are only focused with now with the electropositive series of the metal only. Okay. Now, this is a reaction where a more electropositive metal means the one which is lying at the top. Okay, displaces less electropositive metal which is lying at the bottom. If you will see zinc is above copper, zinc is there, okay, you can see zinc, and the copper is below hydrogen. If you will see, so the one at the top is more powerful, means more electropositive, so zinc is more powerful. So whatever zinc is trying to say to copper, he has to listen to that one. That's the reactivity series, electrochemical series. They have decided that one because zinc is more powerful, we can say, or we can say is more electropositive, we can say is more reactivity. Okay, so zinc is more powerful. So whatever the zinc is going to say, so Cu has to listen. So zinc, why Cu will only listen? Why not SO4? You will try to say. Okay, because Zn is a metal. Okay, it is also a metal. Copper is also metal. So both the metals cannot react together. So that's why they try to remove the metalness. So zinc only removes the copper. Okay, so now is zinc powerful to remove the copper? We have seen by this one. Yes, it is more electropositive as compared to the copper. So it is more, so it is having the power so as to remove the copper from its place of copper sulfate. So now he gives a standing instruction to Cu to has to remove from its place or get displaced or get substituted. Okay, now what will happen? Its definition. Okay, now what will become? Zn-SO4 and Cu will become an element. So it is removing or it is displacing an element. Okay, an element from the compound. Okay, so as to form a new compound, that is Zn-SO4. It will only work according to the reactivity series. So if for example, if I am writing Cu here, Zn here, then also it will work. Then no reaction. Then the reaction will not take place. Why? Because you will see the zinc is more powerful. Okay, zinc is more powerful as compared. I will show you that one also. First you understood this one. Okay, if you will see now, as you told me, okay, to show the electrochemical series for non-metal, so I have showed you that non-metal one. Okay, metal one you understood, that's a non-metal one. Okay, so now you see the top one. So again you see, if we know that this is a non-metal chlorine. Okay, here which one is non-metal? Sir, bromine. So chlorine is going to displace or remove the bromine from its place. So first we have to see whether it's possible for chlorine so as to remove bromine. It should be powerful. The chlorine should be powerful so as to displace the bromine. Then only it will work. Okay, now if you will see the reactivity series. Okay, the chlorine is at the fourth place. Okay, whereas the bromine is below that. So chlorine is more powerful as compared to bromine. Okay, so now chlorine is more powerful as compared to bromine. So what it does, it removes the bromine from its place and form potassium chloride, and bromine will become individual. So a radical or an element should be more powerful and it should be at the top in the reactivity series. It can be a electrochemical non-metal reactivity series or metals reactive series. Okay, then it will be more powerful so as to displace the one which is less powerful and form a new compound. Okay, understood this one? So that is the reactivity series for non-metal. Okay, so how it works? You know, fluorine is there, SO4 sulfate ion, NO3 nitrate, and chlorine, bromine, iodine, hydroxyl. So these are the one which are more priority one. According to the arrangement, you will decide the one which has the more powerful, the one which is less powerful, and the reaction is possible or not. So show us where the reaction is not possible. I will show you that one also, but we will do some of the sums regarding the electrochemical series of metal. Then I will show you how it will work for the one with the lower reactivity series cannot displace the higher reactivity series. Okay. Now if you will see all the three cases, case 1, case 2, case 3. So if you will see magnesium, so magnesium is a metal, aluminum is also a metal, and iron is also a metal. So now we will see metal reactivity series as they are metal. So we will see whether magnesium, so metal, this is metal, wait, we have to identify which metal or this metal. Okay, now we have to see between these two which one is lying at higher positions or magnesium. So magnesium more powerful as compared to copper, so it can displace copper from its position, so it will form magnesium sulfate. Okay, magnesium sulfate, and it will become copper alone. Again aluminum is there, copper is there, so you will see this one, both are metals. So which one had a higher position? Sir, aluminum. Then again it will form a again compound like this. Okay, iron is there. Okay, copper is there, so iron again is lying above copper, so it's more powerful, so again it can displace copper from its position and will form FeSO4 and copper will be alone. Okay, so now if you'll see, okay, so now copper is there and magnesium sulfate is there, so something I have replaced. Now if you'll see where the copper is a metal and magnesium is also metal, so you have to see between these two. So now if you'll see the reactivity series, so which is lying at the top, so magnesium is lying at the top, whereas copper is below of that. So magnesium is more powerful as compared to copper. Okay, if copper will say so as to get displaced from here, so magnesium is going to listen, no, copper is more powerful and more electropositive as compared to magnesium. So what will happen? It is not going to listen, not going to leave SO4. So there will be no reaction. There will be no reaction. Okay, understood why it's happening? Because of that reactivity, what I told you. In case of this one also, see again aluminum is lying above this one, some compound of aluminum, we don't know what is the compound, I will give an example. So aluminum is lying above this one, so it's more powerful as compared to copper, so aluminum is not going to listen to copper, so there will be also no reaction, you understood why it is having no reaction? So that reactivity series is very important in case of everything when you're doing the sums, okay, or when you're doing the equations, it's very important to see the reactivity series, whether the reaction is going to happen or not. According to the reactivity series only we will do the sums, okay. So if you'll see all the metals which are lying above hydrogen, all the metals which are lying above hydrogen are known as active metals. Okay, these are the metals which are lying above hydrogen, these all are active metals. So as I told you, if you'll see the reactivity series, so there are there are hydrogen is there and many metals which are there above as well as below also. Okay, now if you'll see, okay, in this one, this is a metal. Okay, so hydrogen will consider as a metal in this case and this is a non-metal, so we will not consider this one. So metal with metal. So if you'll see in the reactivity series, where is hydrogen, where is metal? Magnesium. So magnesium is lying above hydrogen, so it is more powerful than magnesium, more powerful, so it can easily displace chlorine, so it will form MgCl2 and hydrogen. Okay, so the metals which are above hydrogen, okay, all are active metals, so they have the power to displace hydrogen from the dilute acid. These all are dilute acid, some are concentrated acid also, dilute acids are there, so they have the ability so as to replace hydrogen from the acids. Okay, just like, because see the zinc is also above hydrogen, iron is also above hydrogen, so they all have the power so as to displace this one. So we are getting confused between which one you have to see between hydrogen and chlorine, which one is it? You see in the reactivity series, anywhere chlorine is there, no sir, hydrogen is there, so you will see hydrogen. Anywhere SO4 is there, no sir, hydrogen is there, you will see hydrogen. Anywhere SO4 is there, no. So whatever the thing is lying on this series, you will see between that two, which one is lying above. If it is lying above this one, so reaction is possible, so this is the way you are going to do displacement reaction by using the reactivity series in case of metal, in case of non-metal. Okay.